Good morning, dear participants. It is my great pleasure to introduce Professor Arnab Jana, Associate Professor in the Construction and Technology Management, IIT Bombay. Professor Jana is distinguished academic and researcher with interdisciplinary expertise in urban regional planning, infrastructure system, urban informatics, transport accessibility, housing and informatics, policy making, urban health. His research effectively integrates AI data analytics, economic behavior modeling to address challenges of equitable and sustainable urban development. He holds a PhD from University of Tokyo in MCP from IIT Kharagpur and bachelor's degree in architecture from IIST Shibpur. He is a recipient of several prestigious honors, including the Young Faculty Award at IIT Bombay and Japanese Government MEXT Scholarship. Professor Jana has an outstanding research record of over 150 publications, including papers in leading international journal books, conferences, proceedings, and many of which are have been used in informed policy, planning practices, and governance framework in India and globally. We are indeed privileged to have him with us today, and we look forward to an insightful and enriching session. Please welcome Professor Dr. Arnab Jana from Dr. Bisra Engineering College. Professor Jana, the session is over to you.
Thank you so much, Mr. Roy. It is indeed it's a pleasure for me to deliver a talk about data and informatics, specifically when your program is focusing on smart cities. Uh, I hope that I am clear. I mean, my voice is clear, loud and clear.
Yes, sir, your voice is clear.
All right. Thank you so much. Now, when we look at the smart cities in India, right? So that's the major focus, what we always look for. The thing that we always get, uh, you know, uh, challenged is basically the data. Now, when we are looking at data, the data itself is very complex thing, and what we understand from this particular perspective of data is that how we can manage it. Now, as a group, what we
Sir,
work on. Yes, please.
sir, can you close the meet window?
Okay.
It is not necessary, sir. You can close it and still you will be in meet.
Right. Is
Yes, sir.
it better
It is
now?
fine. Yes, sir. It is fine now. Thank you.
All right. Now, when we look at our research focus that we work here at IIT Bombay, specifically my laboratory, we work on spatial geomatics, we work on econometric modeling, we work on advanced AI models, uh, as well as some theoretical research on transportation, public health, and housing. Now, there is two distinct feature, as you can understand. One is the theoretical part, the other part is the experimental. Now, experimental research that we always try to conduct, specifically with respect to data and informatics, is based on different kinds of sensors, measuring devices, kind of IoT integration. These are things that we keep on using for different kinds of purposes. Now, having said this, you can always, look at it. Now, when we look at the perspective of what we call the data smart cities, now there is something called data smart cities. When we look at something called data platforms, we look at something called city data alliances, city data policies. Now the city itself or urban area itself should have its own policies about how to use the data, how to collect the data, how to integrate the data. Now, of course, these are things which are, most of the cities in India are missing, and therefore this is the reason why there is a dearth of data. Now, the entire process, when we look at this entire process, we something say, okay, to implement a smart solution, data becomes a most important asset. Now, therefore, the entire goal is to have a data driven governance system and leading to urban transformation. Now, that essentially means that what we are intending to do is what we call informed decision making, improved communication, better resource management, uh, using data analytics as issues, creating something called smart cities, and also something called carbon neutral cities. Now, the question is, what is smart cities? Now, a particular space where which is inhibited by a lot of people. Uh, and in this particular context, when we see that there are a lot of interaction between people, space, and infrastructure to create better built environment, that's where the smart cities concepts comes into picture. Now, the question is how accurate is our vision depends upon how good is our data and what is the purpose for using this data. Is it a reactive planning purpose or is it a proactive planning purpose? Now, when we look at the concept of urban informatics itself, uh, you will realize that in this entire thing, every aspect of urban planning, urban engineering, and most of the part of the civil engineering is completely dependent on urban informatics. Now, every of these component actually have what you call one as the methodology and the knowledge of the mother subject, which is civil, and then you have to borrow what you have the technology that is evolving in the field of computer science. And when we are trying to integrate them, now that's the place where the problem starts appearing. Now, which I mean is that you have traditional data, you have open data, you have cyber infrastructures, and you have open source softwares. Now, using this, what we try to do is we try to always visualize, analyze, and train data to develop what you call increased capacity, increase more public engagement, expand the fact base. That means what are the reasons, what are the actual data that is necessary for telling a story, and the new knowledge that evolves for the best urban management practices. Now, in this entire area, there are a lot of problems. Now, the problem here is in three categories. One, when you have no data, okay, that means that the methodology to collect very, very high quality, credible data. Number two is when you have a very good quality data and you don't know what to do with it. And the third is when you have to try to create new methodology for using the existing data or collecting the data such that the new models can be created, new methods can be created. Now, these are the three distinct problems in Indian context. Rather, it is faced by every Indian cities right now, and rather, I would say it is actually faced by every cities of global south. Now, let's start with something more meaningful, understandable. Now, say I want to study the evolution. I want to evaluate the human perceptions of urban surroundings. Say using visual and auditory data. Now, what is visual data? Photographs. What is auditory data? These are sounds, right? That means that I have to collect a lot of data on photographs, specifically photographs. I have to also collect a lot of auditory data, meaning that sound samples. Now, if I say I am going to use this, visual data, there are a lot of algorithms that exist currently across the globe. But if I say I'm going to use a particular kind of sound to find out what is the reason and what is the cause and how effective or ineffective that sound is to, kind of uh, affect the human perception of the urban surrounding, it becomes very complicated. That essentially means that these kind of data in Indian cases are absolutely missing. Now, we don't know how to, I mean, you have no, we have no what you call a database, which we say that, okay, this is an auditory database of the country. However, some of the advanced nations, developed nations have what you call auditory data bank of the country, where we can actually go and actually have a look at those data. Now, for Indian cases, we have to create such kind of data. We have to set up experiments across. So you can see on the map, it's our IIT Bombay campus at the top, and the lower part is what you call Hiranandani area. It's the total area. The overall area is Powai area, right? So when we do this, we try to collect such kind of samples. It has to be done very meticulously. The experimental setup, the way we have to recalibrate what is the baseline of this kind of data, we try to do it, and then we try to analyze each of this particular sound samples. That means that we collect a lot of data, we try to annotate them, then we try to train these data and figure out that, okay, what kind of noises are getting prepared. I can also show you the image. The images are rather very simple because we use very simple AI models. which can be easily calibrated to actually identify. Right now the models are advanced enough to calibrate and identify any of the feature that is there in Indian cities. So that's the level of advancement that is there for the photographic evaluation. But for the sound evaluation, it becomes very, very complex. And right now, what in the focus area on urban perception research has been on how to integrate or rather create new models to have these things done. So one of the major area of research that's happening in our domain in civil engineering and in perception studies is that to create such kind of noise models. Now when we look at these models, we try to understand each of the clips, and then we try to understand each of this particular sound, identify okay which one is specifically a bird, a tree, a movement of leaves, flowing of water, noises from the vehicle, different kinds of vehicles, hammering, using a lathe machine, or whatever. I mean, it can be all calibrated. Right now, these are the kind of calibrations that are getting done, and we have a lot of what we call signature files that are getting created. And very soon, possibly even in Indian case, you will find a database coming up where you will have all of these data freely available, open source, where you can have all of these data very meticulously done, collected, featured, tagged, and you can use those for even for your local purposes. For example, in your locality, if you are collecting such kind of data, these models would be available for free in open source, as well as the what you call the training data set of these will be also be available, so that you can train your own data and do all of this analysis on their own. Now, and then you can actually look at what we call the calmness, the chaotic, the pleasant of these particular cities or this particular streets, and therefore the urban policies can actually happen very meticulously for each and every purposes. Now, why we want to integrate sound in visuals is that the visuals can have one story, whereas the sound can have another story. So we try to understand these difference in stories which varies temporally, meaning there can be a different kind of activity that happens in the morning versus in the evening, and therefore even if I take a photograph from a certain angle which may remain the same throughout the day, but the noise would give me the story continuously. Now, next, we should also try to understand when we have a meaningful data. Now, this is the second step, or more important, very important step towards a smart city. Now, the our country, our all our states, governments, and places have and authorities have a lot of data, and some of these data are extremely good quality. You might say, where is it? But the answer is there are a lot of data that we can always collect and meticulously understand. Now the question is, the example that I will give you is also is a project from the government of Maharashtra, where we were asked to study the emergency medical services in Maharashtra. Now, meaning that even in the state of West Bengal, we have something, a number, right? It's 108 in Maharashtra. When you call, you get ambulance service. Now, when we look at these particular ambulances that are actually applying on the road, the infrastructure that these ambulances have and the data that they collect and the command and control center of the state which actually receives this data are tremendously accurate and extremely valuable. Usually they have a voice logger, a very good quality GPS and GIS systems installed in the system. They have automated vehicle location systems and a very good quality mobile communication system. Using this, they actually collect a lot of data. The screen that you're seeing on my on the screen is that this is an internal system. It's very, very confidential. This is exactly how the entire countries actually the movement of ambulances are monitored. It's not only for Maharashtra. I'm showing you Maharashtra, but for the entire country it is done. We exactly know, as you can see on this particular image, where exactly is the ambulance, what is the speed, which particular road it is, and not only that, what cause, whenever it is made, where it is going, how long will it take. Everything is meticulously collected with extreme pinpointed accuracy. Now, when we get into this kind of data, we have full access to this data. These are extremely valuable data and very high quality. Now, when we do this, you will see, I'm showing you a data, for example, for only 1 month of November. for 2022, in 1 month itself, that this particular call system receives 38,823 data phone calls, right? So it's the 100% data. There is no sampling here. It's a complete data set, and people try to analyze this data to identify two cases. One, what is emergency? Two, is there any hospital to hospital transfer? Because for public hospitals, usually they use 108 as a local service. So to study such kind of thing in this kind of data, we always have to develop new methodology. We have to figure out what is the pain point of the government, specifically if you want to have the smartness coming into it. And therefore, using this kind of analysis, we try to figure out where is the problem and what needs to be done and how. So it is a real project in which we try to figure out the entire episode of time, which is a summation of T6 equals to T0 to plus T1 plus T2 plus T3, 4, and 5, which essentially means that call duration at the call center is T0, followed by how much time does ambulance take to prepare for picking up or receive the patient, which is T1, followed by the travel time to that particular place, which is T2, then assessment of the patient at that particular point, which is T3, the travel time to the nearest hospital is the T4, and then the assessment of the patient's condition at the handover, that time, which is assessed by the medical paramedics, is T5. So this is a complete composition of what we call the episode of a emergency system. Now, when we look at this, we try to also figure out for what purpose was that call made. Is it for hospital to hospital emergency? Is it for male? Is it for female? It is what kind of problem that led to this call. So all of this are analyzed meticulously, and therefore this particular slide would tell you the story that for a given region, what is the necessity preparation for a health infrastructure to run efficiently. Because if that is not done, what will happen is that this T5 will keep on increasing. You would be very surprised to know that this part is extremely high for in the entire country. That means that a particular patient reaches a hospital, but the hospital may or may not be capable of handling that particular patient at a given criticality. That this is a problem that is faced throughout the country. Now, until unless we do this kind of analysis and exactly know what the problem majorly people faces, the hospitals or the health centers are not at all prepared to handle such kind of situation. So, and also this particular data would tell you, because it has got so accurate data, it will tell you what exactly the time and the episode of these calls, at what time the calls are happening and why. Now you see, it's a very interesting trend for first one, the yellow colored graph, which is called the time of the day and the emergency services. You see, emergency peaks at 11 to 12. It's very interesting. Emergency, is accidents or accident. It should not, it should be having a very equal distribution or a very erratic distribution, but there is a clear cut pattern. Okay. Now you see that again, this has a large chunk after, around 5:30, 5 p.m. onwards till night 10. It's very difficult to analyze why this is happening suddenly, but what we realize is that there are certain issues behind it. It's basically the mindset of the pupil. Now, what happens when you do the study in this is that this particular chunk would have a lot of pregnancy and maternal problems, and when you look at these pregnancy and maternal problems, the woman in the household usually wait for their men or their husband to come back and decide whether to make a call or not. And by the time the emergency has escalated pretty high, so the call which should have been made at 1 to 2 p.m. is now delayed by 4 to 5 hours, and therefore the criticality of the patient goes up. Now, this is what happens when you receive a phone call and depends upon people. So this is the time when the men of the households are coming back. It's very interesting, but this is what the smartness of the system gives us, and it also tells us what are the critical analysis that might lead to a better assessment. Now, when we define these episodes, which I already did, you realize that okay, there are very specific things. Now, what are these episodes T1, T2? These very specific things convey. Now, if there is a lot of time taking in T2 and T4, it is poor road infrastructure, lack of connectivity, lack of destination hospitals. Right, this is the criticality of T4. while as T4, T2 would only talk about road infrastructure, lack of connectivity to the base station. Now, T1, if it takes a lot of time, that means somebody saying that, okay, the ambulance getting prepared is taking a lot of time. What does it mean? It means that there is no ambulance. There is a dearth of ambulances which is necessary, or the lack of healthcare professionals which are necessary at the base. Now, T3, if it takes a lot of time, that means that the condition of the patient has become really worse. And sometimes they have to do a first aid, usually at or the first level in what you call response at the hospital itself. Now, T5 is if it takes a large amount of time, that means it is either overburdened, one, two, lack of preparedness, three, unavailability of human resources and medical personnel. So these are very specific. So we can understand that from each of these very specific episodes, we can actually design and derive a policy. And therefore, it can affect how the infrastructure needs to be done for future. So these are very specific interventions. So this happens when you have a very, very good quality data and you have access to this kind of data, and you will be able to analyze very much details, and create new, as what you called, understanding of the country, how it is to be done, when it is to be done, and what is the criticality of the problem. Now, this again, on the graph, you can see there are two types of call, what you call the emergency calls and hospital to hospital transfer. And it also tells you the different kinds of typical problems that we face in Maharashtra. I would say that this would remain more or less similar even for West Bengal, because we have studied other states, and of course the percentage would vary, and this percentage definitely varies with the month as well. So, but that's not the point. The point is, if I look at the top 10 cause of the problem, it will see that more or less the top 10 will remain the same. So the severity is a very interesting thing. We always look at severity of patients which are getting managed by 108 services. And when you see of the severity, you will realize that the severity is a medical term, and it gets a very complex scale. And this scale is here on the screen, which talks about alert, pain, unconscious, unresponsive, and verbal. So these are the kind of level of severity. So this severity also lets the kind of time that one takes. If you are less severe, then possibly the assessment, which is called the T3, which is the assessment of the patient here, and the intrinsic characteristic of the patient, this will reduce. Now, this part is a socio-economic problem, okay, rather socio-demographic problem as well. So that's where the awareness programs comes into picture. Now, what is the ultimate goal? The ultimate goal of these analysis is to always reduce what you call the response time, the time that takes to receive the call at the control room to the ambulance reaching at the incident location. That's called the response time. Now, that needs to be reduced. Now, if you look at the entire Maharashtra, you will find that some of these districts are having a response time of over 30 minutes. Okay, over 30 minutes, while the light yellow color that you see here are between 15 to 20 minutes. Now, when you look at all of this, you see that, okay, these are the districts spatially which needs important or rather very right now you need a lot of interventions, say one of these particular district. Some of these districts would say, okay, these are performing well with respect to others. Now, if you see here, the last one, districts like Amravati, what he says, around 30 minutes. Others are find to have a median response time, and some of these, for example, Mumbai and others, have a relatively lower average response time. Again, which depends upon the time of day at which the call was made. Now, if we look at the incidents that happens across the state and the total time, a total incident location to hospital, right? So that's the total case management time. You see 90 to 116 minutes. That means from the call to reaching that hospital, right? That's the point. From the call to reaching that hospital, sometime it is above 90 minutes, which is very, very critical. As per the theory of medicine, it's called golden hour. So the entire civil infrastructure that one has to design has to make sure that it has to come down below 60 minutes. So whatever needs to be done has to be done such that this 90 to 100, 116 minutes has to come down. Now, this is where the what you call our optimization problems comes into picture. What we call the optimization for the location of the ambulances, such that the ambulance can reach quicker. And where should you locate the new hospitals? That's another locational optimization problem that we try to solve, specifically for the districts which are red in color, or rather above 90, such that these new hospitals can cut down the time significantly. Okay. So these are the problems that now, as a civil engineer, the transport planner, one or transport engineer would like to have into consideration, how to prioritize, what to prioritize, and which particular districts needs immediate attention, which particular road needs immediate attention. All of these becomes very critical to identify through this kind of analysis. Now, when we look at these particular services, these services are becoming very critical because why it is very challenging. Because number one, the data privacy and confidentiality. Now, when we are doing this kind of analysis, we have to make sure that the data remains extremely private, because we are handling with real data, we are handling with real people. So therefore, and the real disease, and therefore, all of these needs to be extremely cautiously handled, and it has to be stored, analyzed, and meaningfully inferred for each of the cases. If you see, when we do a smart city analysis, the complexity is that smart city is not a it's not a single discipline at all. It's a multidisciplinary thing. Now, the criticality of urban infrastructure may not be visibly appealing until unless you do a critical analysis of a problem sector, and that problem sector may not be civil in nature. So here is one of the classic case examples when we see that, okay, this is not a kind of approach that one would take to design or locate a particular hospital, but this particular analysis gives you a much more precise and meaningful. Why I said what the word meaningful is that you have to make sure that you can measure something. Now, to be able to measure a particular outcome, you must have those parameters and indicators in place. Now, here in this case, when we were designing the parameter itself, we have to make sure that each of them are meaningful, each of them can be measured, and each of them has a policy implication. And we have to be also very particular that whether this is India specific, and it does capture Indian culture and socioeconomic imbalances. So that is what makes these kind of platforms very, very powerful. So this is where the multidisciplinary comes into picture. Now, these, as you understood, this kind of demand surges. This kind of demand also falls depending upon what kind of season it is, what kind of cultural association are there for different states. These are all varying. That means that for every state, one has to do this analysis very meticulously. Now, the third part, or the last part, when we say creation of new models and method. Now, say for example, when we try to do a particular city, look at it and try to say and estimate what you call the growth of that city. In general, what we see is that the growth of the cities are measured two-dimensionally, meaning that the area of the city was X. After a wide duration of time, the city has expanded in terms of area. Now, what it does is that you get to see how the cities are growing. That's what we usually follow. But those techniques are specifically good for places, or rather, are specifically good for places which low data availability or no data availability, who are dependent on only satellite data, and therefore such kind of analyses are getting done. But today, in the smart city concept, we do not look at two-dimensional cities at all. We always try to look at three-dimensionally, because the road width most of the time in the core of the cities remains constant, and the city starts growing what you call three-dimensionally. That is, it also grows in height. Right. So you can see on this particular screen, there is an animation going on, which is in doing a simulation of a particular area in Mumbai, which is called BKC, Bandra Complex, which is a central business district inside the city of Mumbai. And you would see that how the three-dimensionally the cities keeps on growing as per our models that we created based on certain data and inputs. So what are the things that we usually do? We try to figure out, okay, what should be the training data? How do you train such kind of model? because you need to have a lot of data to three-dimensionally retrain a city. Say we have this data, we try to measure this particular city, a particular area, say a Navi Mumbai, which was created in late 1970s, 1980s, similar growth trajectory of Rajarhat, but of course Navi Mumbai grew much faster. And you have all of the data, including the height of the buildings, how it has changed over time, the built-up area, how it has changed over time, the total spatially it has changed over time. You have to collect all of these data. And once you do this data and you create your three-dimensional model, these kind of data are very useful in training the data. That means once we train this particular data for the Indian context and we know exactly the models are behaving well by doing what you called sampling and rechecking on the training data for future calibrations, you would see that okay, the accuracy is around 85, 86, 88%. I think that's a good enough accuracy for this kind of analysis, because there is a lot of chances there is what you call a policy change that might happen, which might lead to change in the trajectory of the growth, meaning that sometimes the government changes FSI, FAR. Government sometimes changes certain policies about certain kinds of housing, so that leads to a change of both the three-dimensional structure of the built environment, and these becomes very critical. That's the reason why less than 90%, even 88%, 85%, I would say is a good accuracy for this kind of model. Now, when we do this, how is it useful? First of all, we can look at, okay, what is the infrastructure need, water supply, road, parking spaces, per capita, car usage, energy needs, the amount of it is, how it will impact what you call the heat island effect, how it will impact the city's demand for certain services. Then, of course, you will look at, okay, if can I apply this kind of things for new cities? The answer is yes, you can apply this kind of techniques for the new cities. That means all the greenfield cities that are going to come up, specifically the nodes which are going to come up for different kinds of, say, railway stations. Say in this case, if we take example of high speed railway, so there will be a lot of new nodes that will come up. Yes, we can predict them pretty well, and we can understand that what would be the impact, the volumetric growth of the cities, and what would be the economy that is going to be generated out of these particular nodes. This can be calculated, estimated. The housing demand can be done, the water demand, the infrastructure demand, everything can be done from this kind of analysis. As you can understand, this is again a project that we worked on, and these are very much applied in Maharashtra governments, most of the things. So you can understand the amount of progression the state of Maharashtra is doing, specifically with respect to the MMRDA and other BMC and other places. They have started using such kind of models, so they are pretty accurate, and these models are interestingly very much Indianized in nature. So these are very accurate, and it gives a complete Indian scenario. Now, that's what I was talking about, and what we do is we have the capability, when we do this kind of AI models, we have the capability to look at, okay, what would be the first one, the land cover change, predict them. We can do a build a height map, then we can predict them with respect to any year, any numbers of years. When you combine many other features, I'm not showing all of them due to lack of time. As we can feature many of them, we can exactly know how it is going to impact the entire model. So this is where I would like to stop, because I would like to interact with the people to ask me questions. I'll be very happy to answer all of them. Thank you.
Thank you, sir. It was indeed a informative and very exciting presentation. I would ask the participants to ask question regarding what sir has given the presentation.
Yeah, you can ask me anything.
So, sir, we have offline participants also. We have UG students and faculty members from our institute, and also online participants from different part of India.
Absolutely. Dr. Anupam Vishwas, I think you are muted.
Sir, I have a query.
Please.
So regarding the simulation, so which software we can use? Means from
Simulation.
right,
Yeah,
sir.
please. Please go ahead. First, please complete your question. I will answer it. Yeah.
Yes, sir. My question was to perform the simulation from if from ICT perspective. So which softwares we can use, which
Okay.
will be student friendly also.
All right. Now it depends upon what is the purpose. I will give you examples and purpose. Okay. Say if you are trying to say you want to do a energy simulation, okay, of a building. Energy plus is a good one. uh, it's easy. If you want to do a CFD analysis of the buildings, we usually use ANSYS. But the examples that I showed you, for example, volumetric growth, no, there is no software. You have to create the entire thing. All the, as I said, this is the creation of new models that you have to create. This is not available. So there are softwares which are called 3D GIS, right? There is 3D GIS softwares, but they are not simulations. They are 3D creations. Okay, so to simulate a 2D into a 3D interface with 3D features coming in, the base software that we use, of course, is Python, and the entire analysis that that I showed you at the end regarding the volumetric is completely done only using one software, which is Python. Okay, so now that is yeah, that is good idea actually to put it on the chat box so that I can see an answer. That would be great. uh, usually our softwares, I rather in our group, in our lab, we mostly use Python, QGIS, ArcGIS, and ANSYS, Energy Plus, uh, SPSS, Stata, Art Studio. These are the major things that we use. Okay.
Thank you, sir.
Yes, the chat box. Can I see the chat box? There was some chat coming in. Let me see. Okay, for training in the machine learning, usually use reinforced learning. Uh, what happens is that while we say supervised learning, for different case scenarios, we use different techniques actually. Now, for example, if I'm going to do a auditory data bank of India, right, that's a huge challenging work. That means that data collection is one step. One first is the experimental setup. Second is the data collection. When we're collecting a data, we make sure that the signatures are done accurately. That means it is already not only supervised, it's the experimental supervision has to be done extremely accurately. You have to follow for the what you call something called the Google's handbook. The Google usually does a lot of these kind of data set creation. They have a very specific methodology. There we use supervised classification for those, but usually we do reinforced learning. Second question is, I'm a student of construction management. Yes, you can do a lot of business. Let me tell you, that is one of the major areas that at IIT Bombay we focus on. If you can see that all the examples that I gave you actually can be transferred into business, meaning that I can. We are actually trying to create a complete framework for perception studies, and the softwares are something that we are generating. So of course, it's a complete business model. That's why I said that we do not use any kind of softwares, any borrowed algorithm. We don't use, because number one, there are two problems. I will tell you as a research perspective and industry perspective. As a research perspective, if I'm using any kind of software, any kind of borrowed algorithm, then I cannot hit the top journals of the world. Okay, I cannot publish in the top 10 journals of the world in my sector. I cannot. So to have my papers in those particular journals, I have to have 100% novelty, both in terms of methodology, data collection technique, the objective. All of this has to be ticked. Only then I can click the topmost one. Second is, if I'm from a business perspective, if I'm using some others module, if it is not open sources, there will be a conflict of IP, and therefore a startup cannot be created with a conflict of IP. That essentially means that even for a startup or a business setup, I have to have all of these three correct. So what I would suggest is that, what I would say is that from an academic perspective as well as the business perspective, to excel in any of them, all three steps has to be extremely novel, meaning that has to be absolutely 100% new. Only then you will be able to survive in the market. Otherwise, it's very, 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 very difficult right now, given the advancement that are happening. All right. So I hope I have give you an answer for number two. Uh, Okay, can we integrate one model all smart city requirement like water, waste, communication, travel needs? So it's more okay. Yes, you can, and that would be the holistic idea at the end of 10 years. Right now, what happens is that the type of data that you generate or you get depends upon different kinds of ministries, different kinds of department. The needs are different. Some of them are very critical, some of them are real time. Right, the second example that I gave about the medical emergency is a real time data set. When I said that I can actually see the where the ambulance is right now, that means it's real time monitoring. We have to look at the real time data. When you do a perception study using very advanced AI models, it's not a real time, right? You are analyzing a particular set of time which have a timestamp, but the implication is not real time. While the volumetric growth that you've seen is again a kind of things which you do it for future, say 10 years down the line, 15 years down the line, 20 years down the line. Now the question is, if we try to integrate past, present, and future together, it becomes very complicated. So instead of actually simplifying, we tend to make it very complicated. So what we do is we try to look at the integrate those only which are real time in nature, which is what you call deferred real time in nature, which is not real time in nature, and which is very much probabilistic and futuristic. So all of them are slightly different, and the type of probabilistic model that we usually apply for this are kind of slightly different. So that's the reason why we can integrate. It is not that we can't. In fact, as you said, water management, waste, many of the cities are doing to some extent, at least three or four of them together. Many of the cities are doing it specifically in their advanced command and control centers that these cities have right now. They are able to do some of these integration pretty well. The only problem is that the city infrastructure, what you call the command and control centers that they have, are not really open to public. So that's become a very challenging for the academicians to actually see what is being done. The difficulty that we always look at here is that some of these features are borrowed for foreign countries, specifically in the command and control centers. So there is a technological gap that is happening. Even the know-hows are becoming complicated, specifically while running the command and control center, even for the government and the people who are running the show. So that there is a huge gap, and sometimes even if you have a very advanced command and control center and the integrated ones, people hardly are trained to handle those. Okay, so there is a lot of complications there. I hope I have answered your question. So the two that was there, I tried to answer. So always my because it's an academic gathering, I would always suggest that try to have a look at the very specific novelties that you are trying to work on, specifically with respect to government. uh, this helps you. One, if you see that the articles that I showed you, or rather the research that we showed you, we try to publish most of them in Nature. So the last one is published in, it's called Nature Urban Sustainability. So we try to publish it in the topmost in the possible areas. So please look at the aspects that which will help you to have the novelty in all three aspects, not only one. That is very difficult. Okay, so if there is a requirement, you can collaborate with many other people across India who are very specialized and extremely knowledgeable. So that would be my overall suggestion for it. Yeah. Any other questions? Sheldon. Okay, Puneet. The question is, okay. Do not focus on no, do not focus on private townships only, or do not separate them out. I understand your question, and private townships are slightly easier to handle. I would tell you why. It's because of the homogeneity of the people who are going to use it, meaning the resident of the private township would have a kind of homogeneity in terms of economic, right? May not be in terms of occupation, but Urban local bodies are very complex. It has a large set of people who are from different heterogeneity, heterogeneous background, from occupation, economy, and the way of life. So if you want to focus on a business perspective, easiest one of course would be the private developers. The tough one would be, of course, would be the urban local bodies. But knowing the complexity, I would not say only don't focus only on private townships. But private townships are easy to handle, more doable, lesser heterogeneous. Uh, the clients are simpler to handle. So of course, but your I mean, ultimate goal would be to serve local bodies and help them grow. Regarding case studies, there are not much case studies. I mean, if to be if you give me a very clear asking, I mean, you could ask me a very clear question like uh, uh, a particular case study you want, I can try to help you out by giving you some literature. Usually, case studies that are worth looking at is basically the best practices. I would suggest that you look into UN Habitat best practices. You search in the Google. UN Habitat practices have a large website, and it has very specific types of case studies mentioned, right from housing, travel, transportation, medical emergency. Everything would have a very good kind of compilation. Uh, 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 One would be UN Habitat for medical sciences. You will see UNICEF have a lot of things. WHO has a lot of things. All of these are integrated, by the way. So you have something new coming up, which is called the healthy city concepts, which will be also be there.
जो खनानी ब्रदर्स है उसका हो
Yes, Utsav.
खनानी
Dr. Utsav, you can share your question in the chat box also if you have any
Yeah,
problem with
that would be
that.
easier actually for me. Yeah, there was Puneet has asking. Yes, there are a lot of sewerage systems and others. Yeah, yeah, there are a lot of companies coming up. No doubt about it. There are a lot. If you want to know about a lot of companies that are coming up in this area, what I would suggest is that you look at something called Sign IIT Bombay, which will also have a list of all the new companies or other new startups that are coming up across different areas. You will have a lot of idea what are their concepts, what are they trying to do. And every large organizations are having what you call incubators. Have a look at those incubators. You will also have a very good list of who are these people, what are the new technologies they are using, what are their objectives. Yeah, those are available.
Sir, I have a few query.
Yes, please.
Uh, Sir, what are the uh, present bonding area which the UG student can work in urban planning as a mini project?
uh, I think all of this we are working. I mean, all of this that I showed. I mean, anything. UG students are capable to work on any of these as a mini project. What you can just give them is you can break this down entire things. For example, in the medical, right? So T1 to T6, you just give them that you just work on T1 entire data. Then that can be fragmented into say 10 mini projects. Not any everybody is doing different thing. But somebody as a faculty, you have to sit down and integrate them together. So that kind of mini projects you can always generate. It should be small, but it should be doable. What I my understanding with working with UG students are that they are more than capable. If they want to work, they will work. Now the question is if they want to work or not. Now that's a motivation part, professor. So yeah, so I'm not worried about their caliber or their skills. They are not. They are extremely capable. The thing is that whether they are motivated or not.
Right, sir. It's the primary thing is motivation, and the next things that they come
Yeah,
in
they can do. I mean, every
fragments. They catch all those things. So, if there are any question, no more questions are there. I think.
if you have any further questions, feel free to email me, Shobit. I will answer. I might take a little more time to answer, but I will answer. Sure. All right.
Thank you, sir. It is a great question. It was a very nice and informative session, um, and we would like to thank you from core of our heart, and that you have taken your busy schedule and you have spared some time for us. So thank you very much. Uh, so I would like to ask the participants to have a big round of applause for our speaker.
Thank you. Thank you, sir.
So thank you.
All,
That's
all
all.
right. Thank you so
Have
much.
a nice day, sir. So we will
Have a
have
nice
some
day,
more
sir.
connection with you regarding more sessions, technical sessions, as
Absolutely.
well as future project works
Absolutely.
and
There are
research
a lot
work.
of work happening in my festival. We will connect.
Thank
All
you, sir.
right. Thank you, sir.
Sir, can you share your email ID in the chat box for the participants? They ask for sometimes they ask for communication for the communication. Thank you, sir. So to all the
Thank you, sir.
participants,
Thank you, your kind support and association. Thank you, sir.
Thank you so much. All the best. Bye.
thank you, sir. Have a nice day, sir. Thank you. So we are closing the session. That's all for day six first session. I will share you the feedback, and we will have our next session from 12. Right, right, Doctor.
From 12,
From 12, no? From 12 we will have our next session from 12 p.m. from the next session. Thank
feedback will be shared to you.
you. Okay. So 11:45. 11:45. So our next session will be from 11:45 to the participants. The next session will be from 11:45 a.m. and that will be our concluding session for the FDP. Thank you very much. We are closing the call for now. Enjoy.